Okay. Right, what's going on? Let's see. A cell of EMF E, internal resistance R is connected to a 6, and you get, okay, so we've seen this type before. You've got your cell, you've got your EMF here, and then you've got a large resistor here, right? E or. Yeah? And then we can use Kirchhoff. We can say E minus IR minus IR equals 0. Right? So firstly we have E minus 6I minus I or. Isn't that right? Oh no, actually we know the current, don't we?
Yeah, they asked for the power.
Yeah, E minus 0.39 times 6 minus 0.39 times or equals 0. And then they change the resistor in series with the 6, making a total of 10.
0.24 times 10.
Oh, different current now, isn't it?
Yeah, 0.24.
Yeah? And what do they want?
Because they want the power.
Oh. Okay, so I don't need those just yet, but I feel like I want to do them. I'm going to do them first.
Okay.
Well, question 4 is
I'm doing part 3.
Yeah.
I'm doing part 3 first. So I'm going to minus these, and I get minus 0.39 times 6 plus 2.4. Minus 0.39 plus 0.24. That's minus 0.15.
Yeah.
So that's equal to that times or. So what is that number there, please? 0.39 times 6 plus 2.4 over 0.15.
Should be 0.4.
Mike, can you type that in just to confirm that I did it right?
What?
What is it, Lynn? 0.4 ohms. And is that what you got?
Yeah.
Yeah. And I'm going to do the next part, which is to get the E. So the E will equal, if you can type this in, Lynn, 0.39 times 6, thank you, plus 0.39 times 0.4. 2.49, everyone?
Yeah.
Okay, now let me go back to earlier. Part 1. What is the power in the resistors when they are both connected? So P equals IV, but we don't know the V, but we have the VI-OR triangle. So V is I, you're right, so that's I squared OR. And when they're both connected, we have a current of 0.24 squared times 10. So what does that give us?
0.576 watts.
0.576 watts. Okay, and number 2, determine the charge flowing at any point in the circuit in 5 seconds when both are connected. Okay, so that's just Q equals IT, isn't it?
Yeah.
For one stupid mark. Is it when both are connected?
Yeah, so 0.24 times 5.
Boring. 1.2, isn't it?
Correct.
Easy peasy lemon squeezy. Right, so I've just done 2, 1, 3, 2 marks. Okay. B part 1. State Kirchhoff's first law. This is the loop law, isn't it?
Yeah.
Isn't it? Or no, it's the junction. Which is it? The junction.
No, the junction.
The junction. So Kirchhoff said that if you sum all the currents at a junction, that you'll get 0. And please note, I positive means it's going into the junction, and I negative means it's going out of the junction. Part 2, he says if you sum around any closed loop the voltages, you should also get 0. Positive voltage means it's being provided. And what does negative voltage mean? It's being consumed. Right, I'm flying through this question. Flying through it. So now we can go on to the C part. So what did I say? Don't look at what they ask. Because maybe the order is not the best order. Okay? So let us make the loop rule I1, the junction rule, I1 plus I2 minus 3 equals 0, or equals 3. And let's make two junctions, or two loops. Let's start at the 10. 10 minus 15 minus 6I1, isn't it? Oh my goodness, that gives us I1, doesn't it? Equals 0. So I1 will equal negative, yeah. Yeah. Negative 5, what is it? Yeah. What is that as a decimal? Sorry, 0.833. But with a minus.
Yeah.
But we said that's acceptable. It means they drew the current backwards in the picture, right? And we'll need to make another loop. Oh wait, hang on. This already gives me I2. I2, I should stick it with red. I2 will equal 3.833 amps. Oh wait, this question is becoming suspiciously easy. And let's get the E. E minus 15 minus 8I2 equals 0, right? So that means E will equal, so we need E to equal 15 plus 8 times 3.833. So what do we get for E?
45.7.
Is it this? Now what order did I actually do it in? I did it kind of reverse a little bit. I did. Did I? Oh yeah, because I did this part, well, because the way I wrote it, it looks like, yeah. So I did this part first, yeah. I did this part second, and I did this part thirdly. Ah, guys, this was an easy question now. Wasn't it? It was. Okay. What else is in this exam? Shall we look at another? Let's see. Shall we look at another one? Maybe we'll look at a different year. I don't know. Let's go way back in time. Way back, like 05, 06 or something. Let's see what we got going on. Yeah. Too weird. Interesting. Okay, maybe 05 or 6 is a bad idea. Okay, that's a bad idea. Let's see.
So why does it say is 2008 to 2001 missing and it says no?
Yeah.
But it is missing.
It depends what you mean by missing.
Yeah.
Is it missing in the sense that your teacher forgot to upload it? No, I didn't forget to upload it. It's not missing in that sense.
Why is it not there?
It, do you know that book 1984
Yes.
and George Orwell?
Yes.
And you know the way the government, when they don't want you to know something, they delete the records from the newspapers and all that.
Yeah.
And everyone has to pretend that, like, you know, that's
So what
fine.
happened in 2008, 2009?
Yeah. So the exam was an absolute disaster. An absolute disaster, whoever wrote it. And so, I guess we're all just pretending like it never happened. So they don't put the exams up on their website. So So I wasn't teaching at that time. The previous physics teacher was telling me that, you know, the exam was so bad that every student automatically got a grade increase.
Sure.
Yeah, yeah,
Great year to get the system.
yeah. It was. I haven't seen the exam, but from what I remember, they just, whoever wrote it went overboard with explaining questions. Like everything was explain this, describe this. You know, just went overboard. So it was a disaster. It was a disaster. Let's see now.
But doesn't NCUK check the exams before?
Do you know?
Maybe they did after this.
Hang on. Let me pause the recording.